All right, let me get started. Let me recap what we have discussed so far on Saturday. So once again, good evening, guys. Hope all had a very good weekend. So I'm just resuming from what we have discussed on Saturday. So we discussed about load balancers on EC2. Load balancers are some a component which actually provides high availability as well as load balancing stuff to the underlying instances. So load balancer actually sits in front of your instances and routes the traffic to the instances. So there are basically three types of load balancers in EC2. One is classic, or it's called as elastic load balancer, and the two are network load balancer and the application load balancer. So classic load balancer will be going away very soon, and they are actually concentrating more on network and application load balancers. So every load balancer has its own functionality, has its own options. So depending on the requirement of application or whatever the service you are going to publish on the cloud, so you can choose between any of these three, most probably between application and network. So you will be providing high availability and load balancing options to your application. So to start with, classic load balancer is a minimum option service. So it doesn't have any intelligence involved. So you cannot decide between the specific service based on the port or based on the path. So those two options are provided by the network and application load balancers. So it's a straightforward strategy when you use classic load balancer. So there is no intelligent at all involved. So whatever the traffic being generated to your load balancer will be sent over to the instances directly. So there is no decision making involved in the traffic routing. Whereas with the network, the load balancer can take a decision based on the port. If the application is hosted at port 80, so it should go to some instance. Otherwise, if it is destined to some other port like 8080, it should go to some other instance. That kind of decision making can be taken with network load balancer. In similar way, application load balancer also can take a decision based on the path that you give in the URL. If path contains some specific word, then it should go to a set of instances. If it contains another word, it should go to another set of instances. Such kind of intelligence will be involved. So we discussed about classic load balancer, and we actually went through the options available in the classic load balancer. We just tried to create a load balancer, but we haven't finished it. So in this session, I'm going to create the classic load balancer and show you how you can actually integrate your instances with the load balancer and how the service will be available and how the load balancing will happen. So let me take the queue to the console, AWS console, and we'll see from there. So I have set up the environment in the background. So I've created two more additional instances here. Earlier it used to two. So I created one more Linux and I created one more Windows in the private subnet. So these are the two new instances which come up. So let me power on all of them. And let's go back to our, meanwhile, while they are powering on, let's go back to the load balancers. And so for your information, I also installed IAS on Windows servers and Apache on the Linux box. So I just don't want to waste some time installing the stuff on this thing. So we created the load balancer on Saturday. So it's just sitting idle. It's not actually talking to any instances, I believe. That's what we did. So let me recreate this one and we can see what all options available so that the recap will be also done. So I'm going to recreate the classic load balancer now. And I'm going to give CLB01 as the name and the VPC that we are going to put the load balancer in. So load balancer is again a regional component, not an availability zone specific component. Just make it as a tip like. So if any resource that you're going to create at the VPC level, that's a regional component. If you're going to create a resource where you have options to choose between the subnets, then it belongs to availability zone specific. So in this case, load balancer can span across multiple availability zones. So that's why we're placing it at the VPC level. And an internal load balancer is nothing but a load balancer which actually balances the load which will not be exposed to the public internet. So by default, in any of the deployments, in most of the deployments, a load balancer will be published over the internet, which means it should have a public IP, a DNS name associated with that. It should resolve on the internet. So any of the web servers like google.com or yahoo.com or any other websites you visit daily, they will be actually the instances that are serving this website. Actually, they are sitting behind a load balancer. So whatever we are hitting, that's actually going to the load balancer. Then the request will be routed to the instance that has lowest load at that point of time and lowest number of requests at that point of time. So we just publish our load balancer using a public IP and DNS name. So that will be resolvable over the internet and you will be able to connect to the respective website. If it is a private load balancer, that's not routable basically. So let me give you an example how the private and public networks work actually in the scenario. So you have a Wi-Fi router in your home and you have a cable coming from your ISP like ACT or Airtel or anybody. So in your home, multiple devices are getting connected to your Wi-Fi router. So as long as you have the ISP cable connected to the router, you will be able to access the internet. So once you unplug the cable, ISP cable from Wi-Fi router, you will not be able to access the internet, but you can actually try to communicate with other devices within your home. So using the Wi-Fi router, you can create a network and connect multiple devices together so that they can communicate with each other, but they will not be allowed to go out to the internet because we don't have any ISP connection. Once we plug in the cable from ISP, these machines will be able to communicate with the internet. So that's the difference between private and public basically. So within the network, if you're able to communicate and you're unable to access the internet, that's completely private and you're not visible to the internet. If you have an internet connectivity and your machine is able to communicate with the internet, then we can mention it as public. So internal load balancer is nothing but within your instances, within your private subnet, you will be placing your instances behind the load balancer. If that is your requirement, then you have to create an internal load balancer. So what port that should the service is running on and what port should the load balancer listen on? So by default, most of the websites runs on 80 port, or if you have a customized port like 8080, you can mention it here, so that this load balancer can take the request on port 80 and forward it to the instances, backend instances. So as we are creating the load balancer as a public one, we need to definitely place this particular component into the public subnet, because whatever instance that you place into public subnet will be assigned with a public IP by default and also public DNS. So that is our requirement. So we're creating this load balancer as a public load balancer, so we should place it in the public subnet. So in this case, I'm choosing 2 availability zones within the same region. So my load balancer will have high availability. If one availability goes down also, the other availability has the load balancer available, and our service will continue without any interruption. So I'm placing this load balancer within 2 availability zones within North Virginia region. So in the back end, 2 load balancers will be created, but it will be presented as a single instance for us to configure. So I'm going to network security groups. So I'm going to allow the HTTP only, so I'm going to create a new one. I don't want any other ports to be allowed. Allow HTTP, and my protocol should be HTTP. Where's this? Right. So source is from anywhere. Zeros means anywhere. So I'm just creating the security group, and so now I wanted to configure the health check. Why the health check is important? So load balancer has to determine whether the instances running behind are up or not. Are they available or down? That has to be determined by the load balancer. If something goes wrong with any of the instances behind the load balancer has to identify that instance and stop forwarding the request to that particular instance so that the others can take care of the request. If that is not happening, if load balancer is not aware of the health status of the instances, what happens is, if you have two instances, one of the instances goes down, and every second there are two requests are coming in. So if load balancer is unaware of the health status, it will forward those two requests sequentially. First to first instance, second to second instance, third to first instance, so on. So every other request will be actually failed. So every second user in the sequence will get the error. So to avoid this kind of errors, load balancer has to have the idea of the health status of the instances. Idea about the health status of instances. So how a load balancer can actually identify whether an instance is running or not. So it will identify by doing some health checks. It can ping actually if it is pinging is nothing but sending a request continuously. Either it can be HTTP request or TCP request or HTTPS request, whatever it is. So what we are doing is we are just configuring one of the page to be accessed from the instances. So if all the instances have index.html in the root folder, so this load balancer will try to access that page every at a specific interval that we define, and if it is unable to access that page, it will mark that instance as unhealthy and remove it from the pool so that the request will not be forwarded. So removing in the sense, it will not remove completely. It cannot take a decision to remove from the pool, but it will stop forwarding the request to the unhealthy instance. That's all. So if you are creating a website and you're placing your web site related files, then you should specify one single file from every instance, because those are mirror images of each other. So every instance will be having same website files. So you have to mention what file should be accessed from the load balancer. So every 5 seconds or 30 seconds, it will try to access the file. If the file is unavailable or if the server is down, obviously the file will not be accessible. So in that case, it will mark as unhealthy. So for our demo purposes, I'm deleting this file name here. I'm just sticking with the root. So it will directly hit the root folder. And if the root folder is found, then it will show it as healthy. That's all. So I'm going to continue. So next we can add our instances to the pool. So how many instances should be there behind this load balancer? So we have 2 private Windows instances and 1 public Windows instance. So before we move on, let me go ahead and add these 2 instances. So I have configured the web service on this. Okay, let me go back to the EC2 console and show you what I have configured so far. So there are 4 instances running, 1 Linux and 3 Windows. So I have created 2 private instances. They are not actually accessible via internet because they are in the private subnets. So to access these guys, I've also created a public instance to which I'll establish the connection, and from there I'll log into these machines. So I'm using this public Windows machine as a gem box simply. So, and also I did a modification, like I've changed my password to a standard so that there is no need of going back to get Windows password and providing that key to generate the password. So I just configured my password, default password, so that there is no need of going here. So I logged into the public instance first. From there, I'm going to log into the private instances, both of them. So let me take the IP for them. So first I'll go with the private Windows instance. This is the IP. So I've changed the password for this guy as well. And I'm going to log into the other machine also, which is 10.4.102. I'll show you where it is getting logged on. Oh, okay, I haven't generated password for this, I guess. So this guy is 3.53 and this guy is 4.102. So let me go back and get my password generated for this. So I think I haven't generated the password for this yet. Okay, first of all, let me reset my password so that will be easy for me to demonstrate. Administrator. So what I've done prior to the session is I went ahead and installed the IIS service using the server manager. So this guy and the other Windows machine, both of these machines have IIS installed now. As you can see here, there is a role IIS has been installed. So let's go ahead and check the other machine also. And for the purpose of convenience, I have kept the default website. I haven't done any modifications except the default website actually shows you an image about the IIS. So I went ahead and added some information about the server. This is server 1, which is at 10.0.3.53. And the same way I've configured this image on the second instance also. So let's go ahead and quickly access these machines from the public instance. First of all, 10.0.3.53, one of the instance. So I've accessed it and it is showing me the welcome page of the Internet Information Services, which has 3.53 as the IP. And the other one is 4.102. Yeah. So I'm going to hit it as well. So both of the servers have website installed and they're available now. So this is the minimum configuration that I did. So I'm going to these particular instances, which are definitely not accessible from the outside world. We cannot access them from our laptops directly. So that is the reason I'm accessing them from the public instance. So let's go ahead and continue with the creation of our load balancer. So I've selected these two instances, which are Windows. I'm going to next, and I'm not going to give any tags here. So let's go ahead and create the load balancer. Now our load balancer is getting created with two instances behind serving a website. So let's see how this particular instance can be, this particular website can be accessible from outside world. So when you go to instances tab, so currently it says out of service. Both of the instances are there, private Windows 1, Windows 2, and currently their status is out of service. As you can see over the pop-up, it says instance registration is still in progress. So once the registration is completed, then you can come back and access your website or your load balancer using the DNS name provided here. So this is the name which is resolvable over the internet, which has been generated by AWS, by the way, and it is also associated with a public IP in the background. So once the instances are ready to be served, and then you can actually hit this URL. So you will be reached to one of the instances which I shown earlier. So you can see the instance name where you are hitting in the website image. So once this is complete, we can actually see that. So this is the classic load balancer configuration. It doesn't involve any of the additional configuration. It's a straightforward setup. If you want to add more instances, you can actually go ahead and select your instances, click on save. That instances will be added to your load balancer and will take the load from there on. So now in this case, it's a 50-50% load. So we have only 2 instances serving the purpose. So in a round robin fashion, each request will be forwarded to a single instance. So first it will be hitting first instance, and second will be hitting second, third is going to first, fourth is going to second. So and so on. And connection draining, we discussed it. So if you want to remove an instance from the load balancer, you can remove it. And when you remove it, it will wait for 5 minutes to actually drain all the connections, all the established connections that are there on the instance so far. So connection draining is by default set to 300 seconds. If you want to increase, you can increase that as well. So this is most of it about the load balancer. So now, as you can see, it's in service. Earlier it is out of service, now it is in service. Let's go ahead and quickly try to hit this DNS name from our laptop directly. Now this is a public load balancer, right? It should be able to access from any of the chain over the internet. So our first request has gone to server 2. So second instance has taken the request. If you refresh this, there are most likely there are chances of hitting the first instance. So if it is not going to the first instance, the request has been cached. So we need to use another browser to see whether it's going to another instance or not, or maybe another browser. So it's only going to server 2. Yeah. So as you refresh, you can see that your request has been also forwarded to server 1. So any of the instances goes down in this case while the load balancer is handling the traffic. So that instance will be taken out of the pool, which means it stops sending the request to that particular instance, and the rest of instances will take the request. So your service will never go down. So this is how you can actually take advantage of the load balancer. So this is about classic load balancer. So let's move on to the other topic. The next one is in our list is network load balancer. So what's a network load balancer? It is similar concept actually. There is no bigger difference from the point of basic functionality of a load balancer. So a load balancer usually provides high availability and load balancing stuff. That's all it can do. But with the network load balancer or application load balancer, what happens is you can actually take a decision if your website is being hosted at some port 80 or some port 8080. So depending on your configuration, you can actually route your request to the specific set of instances. So most of the options are similar, but when it comes to the listeners, like you can add multiple listeners. So network load balancer can only do the routing based on the port numbers only. There is no other way around. There is no other functionality associated with it. It can only distinguish between ports, and it can route the request to specific set of instances. So let's go back to the console and deregister our instances from here and attach them to the. So to do the deregistration, you just need to uncheck your instances and save. Otherwise, you can also click on the remove from load balancer, and that will take care of the thing. So we just removed our instances from the load balancer, but it should be still there for about 5 minutes because the connection draining is enabled here. So this load balancer is now empty. Let's move on and go ahead with our network load balancer. I'm going to delete this because it's going to charge something for me. So I'll go and create another kind of load balancer now. So let's go ahead with network load balancer. So again, request limit exceeded. Okay, it's a free tier account, right? So request limit has been exceeded for this account, I believe. Okay, let's see. Perfect. says the same thing again. Yeah. So our previous request is being still handled, the deletion of the classic load balancer. That's why I think it actually gave the error. So NLB01, and it's an internet facing load balancer, and we don't need an internal at this point of time. So I want to listen my website to I want my website to be listened on either port 80 or and also port 8080 also. So I'll go ahead and add one more port here. I have two listeners now, and I'm going to create my load balancer within the VPC. I'll select my public subnets. It's all same as you see in the earlier one. So I'm going to select the same subnets, and these guys will be having IP addresses assigned by AWS. Is there anything that I'm missing here? Can't see all the options. Okay, public subnet and public subnet. Okay, let's move on to configure security route. I think for some reason it's not generated in the earlier screen. Okay, so we don't have an option to actually configure the security group. If you can remember from the previous creation wizard, we have also associated classic load balancer with a security group. So in here, we don't have any security group associated with this particular load balancer. Why it is not there, I'll let you know in the demo, like when we move forward. So configure routing. So this is where the target groups comes into picture. In the Elastic Load Balancer, we don't have any concept of target groups. We just configure our instances to be attached to the load balancer directly without a concept of target groups. So for network load balancer or application load balancer, we should create target groups and attach them to the load balancer. So we don't have any target groups at the moment. So I'm going to create one now. So I have a Linux instance and I have a Windows instance. So I'm going to use both of them. So I'm going to mark them as PG Linux, and protocol port is by default. My Linux machine is running on port 80. So let me show you that real quick as well. So from the public machine, I'm going to access my Linux instance. So this is the IP of Linux instance. So I've configured Apache browser on this machine. So you should see a welcome page from the Apache if it is already started. So it's not started, I believe. So let me put T into the machine. So for the Linux machines, if we want to establish the connectivity, you have to have your private key with you, copied over to your machine from where you're connecting, and go to the SSH tab and go to the authentication options. You need to provide the path for your key, and the default user for login to the Linux instances is ec2-user at the rate of IP address. So this will actually allows you to log in automatically by using the key inside your private key. So I provided my private key for the authentication, and also I provided my username. So once I open the connection, I'll be directly authenticated. It's not asking about any password here. So for the Linux, you will do this authentication like this. So there is no generation of passwords from the console or something like that. You just need to copy your private key to the machine where you initiating the connection from, and you need to provide the path and use the EC2-user as default user. So I'm going to switch to sudo, that is root user, and I'm going to start the service httpd start. So it just started the service. Till now it is not started. So let's check the status of the service. So it started and it's running perfectly. So let's go ahead and access our Linux website. So now you can see the Apache page from the Linux box and IIS page from the Windows boxes. So we already hit these things. So Now I wanted to make my Linux instance be running on default port because I don't know much about Linux to change the porting. So I'll go ahead and change my Windows port. So I want my Windows instance to be running on different port instead of default 8080. So what I need to do is I need to go ahead, launch the IAS and select your default website. Within here, if you can see, it's running on port 80. So you need to go ahead and click on default website, advanced settings, where you can actually change your port basically, or otherwise you can go to the bindings. Here you can edit the port number to 8080. So once you do this change, you have to restart your web server and go back and try to hit the URL from here. You should not be able to, because we have changed the port number to 8080. And to establish the connection, you must present the port number also. In this case, it's not still allowing us. What might be the reason? If you can guess, it is the problem with the Windows firewall. So Windows firewall by default only allows port 80. So we need to go ahead and make some changes in the Windows firewall to allow port 80. So I'm going to the Windows firewall options, advanced settings, inbound roles. Here I'll define a rule. So remember guys, if the website is not accessible on custom port, that is like 8080, you also need to make a rule on the Windows level also. Otherwise you won't be able to access the website. That's a must. HTTP custom. That is the rule name, and I'm going to allow it from anywhere. So now I have allowed, and I should be able to reach to this website. Yep. So my Windows instance website is running on port 8080 and Linux is running on default port. So let's go back and go ahead with our configuration. So we haven't created any target groups. So target group contain one or more instances. It's not a mandatory requirement that you need to place multiple instances in the target group, but having multiple instances will provide you higher redundancy within the target group. If this single instance fails, your website won't be able to won't be accessible at all. So that is for that reason you should create multiple instances within the target group. Otherwise, for the demo, single instance is fine. So TG Linux, I'm going to make it run on port 80, and the protocol is HTTP is fine, and I'm going to health checks. This is all about. I'm going to access my root page itself. So again, we have intervals, healthy intervals, timeout, and stuff like that. So based on your requirement, you can actually configure these things. Otherwise, you can leave it as it is. So this particular thing will be going to create a target group here. If you can see the target group section, we don't have any as of now. So there are no target groups created so far. So with this wizard completion, you will be having your own target group created here. And next, register your instances. So what instances should be part of this particular target group? So I have a Linux instance. I have to select that, and on port 80 it should run. So I'm going to add it to the registered instances and click on review. So we still have configuration pending for a Windows instance. So we'll come back once this is done. We'll create another target group and assign a different port for that also. So this is getting created. Our load balancer is getting launched. So it will take us to the load balancer page right now. So it's still in the provisioning phase. So while it is getting available, I'm going to go ahead and create one more target group, which includes Windows instances, PG Windows, and the same. I want the instance to be running on port 8080, or website is running on port 8080. So HTTP on all request. Nice. All right. So target group is created for Windows also, and we need to go ahead and attach our instances to the targets. So edit the instance that we have customized the IIS on is Windows 1. So I'm going to use it, add registered, and click on save. So once both of these target groups are ready, so one target group contain instances related to the Linux, and one target group contains Linux related to Windows. So as you can see, this particular instance we have created during the load balancer creation, and it's in the initial state of configuration. And if you see the Windows box, it's still unused. It's not attached to any of the load balancer. So we need to go ahead and attach it to the load balancer so that the traffic can be routed based on the port number. So once the load balancer is ready, we can move ahead and do this stuff. Otherwise, while provisioning is happening, we can go ahead and go to the listener tab. So we have 2 listeners available right now. So when we create the load balancer in the first page, we actually provided that information. So these are the listeners basically. So you need to provide your listeners information. So that's what we did. We have also added a listener for 8080. So both of the listeners, if you can see, they are forwarding the request to TG Linux group, which shouldn't happen. What are the requests that comes on 80 should go to Linux instance. What are the requests that comes on 8080 should go to Windows instance. So we'll just go ahead and click on this, select edit, and change the target group to Windows. I think it might be service limit for me or something like that. Otherwise, if you have the option enabled here, you can select your Windows instance, and whatever the port traffic you generate on the port 80 will be redirected to the respective instance basically. So I think I have some service limitations, I believe, so that's why it's not actually showing up. So we have the listener ready, we have the instances ready. So if you actually go ahead and edit this particular configuration and forward it to Windows, so then you should be able to hit your website on port 8080, and when you will see port 8080 that is from Windows instance. So IIS page will be actually shown to you. Or else let's wait for the this guy. Edit. This is the default. For some reason it's not getting selected. I think I have some service limitation. So this is how actually we can configure the load balancing stuff. So what I'll do is I'll try to sign up for a pay-as-you-go model, and I'll show you how this thing can actually work in the real time. So what we have done so far is we have created two target groups. One target group contains one Linux instance, and one target group contains Windows instance. So let me so this guy is still in the registration process. Let me finish this. Okay, I believe I should use, I got it. I think the protocol should be TCP, I believe. Let me recreate this. So I'm going to create the target group again for Windows, PG Windows, and let's go ahead and do that stuff. So health checks TCP, that's fine, and let's create this. So our Windows target group is created. Let's go ahead and add our instance to the registration process. So it's still unused. Let's get back to the load balancer stuff, and let's see if it allows us to change. Yeah, now it is allowing us to change. So It's a small thing that I did a mistake. So instead of TCP, because network load balancer only allows TCP traffic, application load balancer allows HTTP traffic. So TCP, HTTP, those are different protocols. But when you select network, network includes all kinds of protocols, basically FTP, HTTP, RDP, whatever the protocol it is. TCP is a combination of multiple protocols. So network load balancer actually treat every protocol port as a TCP. And when you configure application load balancer, it only handles the application request, which is a web application by default, and only HTTP traffic will be handled. So we don't need any other protocol to be handled using the application load balancer. So now it is allowing us to forward our request to port 8080. Whatever the request that comes on port 8080 should go to Windows target group. So let's, I just edited this rule and I modified it to forward it to TG Windows. So Windows instance will be involved in the registration process also. So this is done. Let's go back to the target groups where you can see the actual status. So by this time, Linux instance is still okay. It's still instance. Okay, unhealthy. So why it is unhealthy? We need to take a look what we have mentioned in the health checks. So we used our protocol and default route path, that is fine. Now let's go ahead and change this to TCP. It's not there. So default route traffic port. The path is fine and everything looks good for me. Okay, it still says unhealthy. Health checks failed. And this guy is getting into the initial configuration, I believe. Yeah, target registration is going on. So what's wrong with this? We don't have any additional stuff. So root, in the sense, probably it is as it is a Linux box. ls var www.html. Okay. So okay, let me create a file here. This is the root folder for Apache and Linux. I don't think we have any files here. So let me create a file real quick. Touch index.html and vi. That is sufficient, I believe. Okay, we don't have any index.html. So it's a blank page. So anyway, we have a page to access now. So I'm going to change the health check to include this index.html page now. So let's see what happens. So this is how the real-time problems comes up, and we need to troubleshoot. Again, it actually goes into the health check when it check for the interval 30 seconds. Let's decrease it for our demo seconds. It's not there. Okay, so let's wait for 30 seconds and automatically it will try to hit the URL using the index.html in the URL. So definitely it will find out and it will become healthy in a couple of seconds. Let's wait for that. So it's going to check again after 30 seconds. Meanwhile, what's the status with Windows? So this stuff actually takes a little while for the configuration because load balancer has to do the health checks and stuff like that. There is no agent installation involved in the load balancer configuration. It's just a straightforward health check that happens during the registration of instances. So, but it takes a little bit time based on the intervals that we define. So if it is less than, I think, 5 seconds or something like that, the health check will be quicker, I believe. So this is healthy. Let's see what happens if we hit on port 8080 from our public DNS name. So this load balancer now ready with Windows instance at least running. So I'll go ahead and hit this URL directly. By default, the port is 80, so we won't see any page because Linux instance is still having problems. So I'll customize this thing, and with 8080 I'll try to access. I'll be taken to the Windows instance. So if the Linux instance is ready, there's no need of giving any port number here. So you'll be taken to the Linux Apache page directly. So once the instance is up, we can see that too. So this is how actually we can use the network load balancer healthy. Yeah, so we can see healthy as the status. So probably it's going straight away to index.html, I believe. So let's go ahead and make a little change here. So I've created the index.html, nano index.html. So how is it? Nano is not there, which is an editor for Linux, like Notepad. So I just installed it, and I'll go ahead and welcome to the Linux world. So I just written some stuff to the HTML page so that we can see, and just restart. I don't think it is required, so we'll just hit this here first. Yeah, so our Linux page is also showing something. So let's go back and hit the URL directly. So now we are able to hit the Linux website with the default port of 80. We're not mentioning any port here. So anytime we hit with default port, that is 80, you will be taken to the Linux target group. As of now, we only have one instance inside the Linux target group, but you can have as many as you want. That's fine. And if you want to access Windows website, you need to specify the specific port. It's the same case with Windows also. If you want to provide redundancy, then you should have multiple instances behind the load target group so that you can have high availability and also load balancing. So this is how the network load balancer can be utilized. So now our both of the instances are healthy, Windows and Linux also. So I'm just recapping what we have did so far because I might have gone quickly, but it's a confusing topic also because of classic and network load balancers. So classic load balancer doesn't involve any intelligence, but network load balancer, you can actually use port-based routing. As we saw, we can route a specific port. So for the both websites, the DNS name is same. See, this is a DNS name generated by Amazon. If you want to have your customized DNS like www.cloudspark.com, on port 80, if you hit, it's going to open your 8080 specific website. So the DNS name will be same, but the website that is serving on different port will be presented to you. If it is a default port, you can directly enter this particular thing, the DNS name. Otherwise, you need to specify the port. So the DNS name, public IP, both are same for both websites, but they are coming from two different worlds, two different set of configurations. So if we can see, we can so yeah, let's go ahead and see these also. So load balancer also has delayed protection. If you can remember from the EC2 instance class, we have termination protection there, so which actually prevents you to delete the instance. If you're deleting the wrong instance, this will save you from making mistakes. So if you enable this, you'll be prompted. You have enabled delete protection. You want to disable that before you're going to delete. That's how it is. Class zone load balancing, as I showed you earlier in the class. So if the load balancer within the availability zone goes down, this load balancer, our load balancer is spanned across multiple availability zone within the region, right? So in the background, if you choose 4 availability zones, it will be spanned across 4 availability zones, and 4 load balancers will be available in the background. So if one of the load balancer goes down from one of the availability zone, the other can actually forward the request to the instances in other availability zone. That's how the cross load balancing, cross-zone load balancing works. Access logs, if you want to have your logs related to the load balancer, you have to create a storage account which is on S3. If you have a bucket already created, you can give the URL here so that your logs will be redirected to that for the troubleshooting purpose. If you don't want that, you can uncheck. So these are all the options we have, additional options. Okay. And let me show you real quick with the creation of the load balancer and recap everything in just a second. So why we are not actually creating the security group here. Let me go ahead with this. And so once you create the load balancer as internal, you will not be having the DNS name, public DNS name as this. Whatever the DNS name that this particular website is associated with. So this DNS will not be available as public DNS. So if it is an internal, it's only available within the instances. You're only able to access from this instance, public instance or other private instances. So if it's public, then you can hit from anywhere. The name. So here we need to remember that network load balancer only handles protocols as TCP. So you need to provide your TCP, TLS, either of these. Not HTTP. HTTP also can be handled, but it is a TCP protocol by default. It's a part of TCP IP stack. So network load balancer handles all the protocols as TCP IP. So if you want multiple listeners, if you have your service published on multiple ports, then you have to create multiple listeners here, and the websites can be published from multiple ports and from the different target groups. And you need, as it is an internet-facing load balancer, you must place your load balancer within the public subnet. A public subnet, if you can remember, when we enable public IP assignment for the subnet, it becomes a public subnet, which is accessible through the internet from anywhere. If it is a private subnet, the public IP will not be assigned for the resources within the subnet. So it will not be accessible via the internet. So if you're creating an internet-facing subnet, the load balancer, you must place your load balancer within the public subnet. That's the only option we have. If you create it internet-facing and put it in private subnet, which is not accessible, it doesn't make any difference. It doesn't make any sense. First of all, you want your load balancer to be internet-facing, and you're going to put it in the private subnet. Private subnet by default will not be assigned with any of the public IPs. So if you can see, a load balancer must have a elastic IP associated with it. So private subnets don't have any elastic IPs. Public subnets will be having elastic IPs assigned. So you need to place the load balancer in the public subnet only. So next screen, we don't have any load security group here. Why does this thing is hidden? It's not actually. Okay, sorry, it's moving. So we don't have any security group associated with the load balancer. So the primary difference between application load balancer and network load balancer is whatever the request that is sent to the network load balancer will be forwarded to the instance directly. So where in the case of application load balancer, the request will be terminated at the application load balancer and then forwarded to the instances, which means, so for example, I'm hitting this load balancer from a browser. So which means whatever the packet that is initiated from my machine, my laptop, will have its own IP address, hostname, and the rest of the information associated with it, network packet. So once the packet reaches the network load balancer doesn't see any information except the destination address, or it doesn't have any destination address also. So it straight away forwards the request to the respective target group. It doesn't make any modifications on the packet level, doesn't do anything at all. So it'll straight away forwards your packet. So whatever the packet that is originated from your laptop will be taken to the instance directly. Whereas in the case of application load balancer, there will be a modification done at the application load balancer level, and after the modification only the packet will be sent to the instance. What that modification is, so when you hit the URL from the using a load balancer, the source address will be preserved, which means the instance can see your address as the source, not the load balancer as the source. So what is happening is we are actually sending our traffic from a client to a load balancer here and to the instances. So the source is this guy actually. So it has an IP address associated with it. It has a host name associated with it. So once you initiate a request to the website that is hosted using the load balancer, that request will be forwarded to the load balancer. So load balancer take that packet and forwards it directly. Once the packet reaches the destination, one of your instances can see the source address as the machine name, machine IP, not the load balancer. Where in the case of application load balancer actually changes the header of the packet, TCP packet, removes the source IP, source hostname information, and it puts load balancer IP and load balancer name as the source, and then forwards the packet to destination. So instance can see the source as the load balancer. It doesn't know where it comes from. All the instances will be assuming that all the packets are coming from the load balancer only, not from the actual source. So the packet modification will be done at the load balancer level in the application load balancer basically. So for that reason, security groups will not be included in the network load balancer. So whatever the security you wanted to provide, you have to provide it using the instance level security group. So the packet will be directly forwarded to from source to the destination. There is no modification, nothing will be involved. So here there is a chance of this guy is getting exposed, or maybe something can happen. So the security group associated with the instance will take care of the firewall stuff. But where in the case of application load balancer actually changing the header of the TCP packet. So all the packets sent to these instances will be having the same load balancer name, same IP. So which is known to all instances by default, right? So all the instances behind the load balancer will have a knowledge of load balancer name and its IP. So in the application load balancer, all the packets are getting modified with the load balancer as the source. So it's a trusted communication between these two parties. Hence, there is no security group. There is a security group associated with the load balancer also. So here you need to prevent what is coming from the actual sources. So that's why we create a security group in here. We'll move on with the application load balancer tomorrow. When we create that, you can see security groups associated with the load balancer itself. So additional layer of security will be introduced here. So the prevention of unknown access can be terminated at the load balancer itself. Where in the case of network load balancer, the requests are straightforward going to the instances. So instance specific security group will take care of the rest. That's why we don't have security groups when we create this particular network load balancer. So when we move on the routing part, we created our target groups. So by default, we only create one target group during the wizard, and additional target groups can be created from the EC2 console and associated with the load balancer. So these options can be modified to up to an extent. So these defaults cannot be modified, others can be modified. So this is how we can actually add our target groups and stuff like that. Then the next step is to create register the targets. We need to select our targets. What are the available targets? Targets are nothing but instances. We need to click on that and add to register so that it will get associated with the load balancer directly. Once we've done that, our load balancer will be created, and instances in that target group will get its registration process initiated. Once we are done with that, we need to go ahead and change our listeners so that it can go to the respective sites. So if it is we defined in such a way that our Linux machine has to host a website on port 80 and Windows machine has to host a website on 8080. So we created two listeners and we are forwarding our request to the respect to target groups. So that's all for today from my side. If you have any questions, you can ping me offline, or you can ask me on the Excel sheet, wherever you want. So we'll move on with the application load balancer tomorrow, and I'll upload this session once this session is complete. Thank you so